Hello everyone, welcome back to Chemistry Online class. Today I'm going to continue with calculation of solubility. In the first video I treated the calculation of solubility in mole per dm cube and in gram per dm cube using two Jamb questions. Today I'm going to treat the remaining aspect of the calculation. There are some special calculations questions that are usually asked. Questions like, is a solution saturated or not saturated? That is from your answer that you get. So let's consider the first question here. Please, before I move on with my class, if you are new on this channel, please don't forget to subscribe for me, like my video, share my video to those that are in need of it. So let's move on. The solubility of a salt of molar mass 101 gram per mole at 20 degrees Celsius is 0.34 mole per dm cube. In this case now, the solubility has been given to be 0.34 mole per dm cube. If 3.40 gram of the salt is dissolved completely in 250 cm cube of water in a beaker, the resulting solution is A, saturated, unsaturated, and so on and so forth. Now, all the information we need has been given in this question. If you can still remember, in the first video, I used this formula for calculating solubility in mole per dm cube. Solubility in mole per dm cube equals to mass over molar mass times 1000 over volume. Now, if you look at the question, the volume given here is 250 cm cube. The mass of the salt is 3.40 gram. The molar mass of the salt has been given. You don't need to calculate it. In some cases where the molar mass is not given, the name of the salt will be given and you have to work out the molar mass. So please, I want to remind you to always learn. If you are weak in writing chemical formulae, you need to go back to it, learn how to write chemical formulae clearly, because if you miss it from the chemical formulae and you use it to calculate the molar mass, you will get the question wrong. So I've made a video on how to write chemical formulae correctly. You can check my video on that. So the molar mass has been given in this case, so you don't need to calculate the chemical formulas. And what else has been given? The solubility itself that you're going to calculate has been given. So what they are trying to say here is that if 3.4 gram of salt dissolved in 250 cm cube of water to give a solubility of 0.34 mole per dm cube, is that solution saturated or not? That is, the 3.4 gram of salt that was added to the 250 cm cube of water, is it up to what's supposed to be added, or is less than what's supposed to be added, or is more than what's supposed to be added? So in this case, what we are going to do is we will pretend as if we don't know the mass of the salt. There are two ways. You can put unknown x to represent the mass of the salt in the formula, or you use the same mass of salt and then you calculate the solubility for this particular mass of salt. You will see that there will be a difference. So let's pretend as if we don't know the mass. We want to know the actual mass or amount of salt that we give a solubility of 0.34 mole per dm cube of salt. So solubility has been given to be 0.34 mole per dm cube is equal to mass. We don't know the mass yet. According to what I said, we are going to look for the actual mass of salt that will give a solubility of 0.34. And the molar mass of the salt has been calculated as 101 gram per mole. So you don't need to work it out. So in this case, the solubility has been given, and then the molar mass has also been given. So we will calculate x, and then we have 1000 in the formula over volume, which is 250 cm cube. Now, cross multiplying, we simplify the values. 101 multiplied by 250. So if you cross multiply, we have 1000x equals to 0.34 multiplied by 101 multiplied by 250. Dividing both sides by 1000. Okay. So we end up having 250 here 1, 250 here 4. So we have 34.34, which is by multiplying 0.34 and 101 divided by 4. And the final answer is 8.585 gram. That is for a solubility of 0.34 mole per dm cube. The actual mass of salt that's supposed to be added or that would have dissolved in 250 cm cube is 8.585 gram. But in this case now, 3.4 gram was added or was dissolved in 250 cm cube of water. So in that case, it means we have less salt than the solution can actually dissolve. And according to the definition of unsaturated solution, an unsaturated solution is a solution that contains less than the amount of salt that the solution can actually dissolve. So in that case, it means it can still take more salt to be dissolved. And if a solution is saturated, it means it's already okay for that volume at that particular temperature. So for a saturated solution, is a solution that contains more than the amount that it can actually dissolve at that temperature, because you will see it in the presence of undissolved solutes. When you add salt to water, for instance, and you keep on adding salt to the same quantity of water without increasing the quantity of water, at a point you will see that some salt will remain, they will not dissolve again, they will remain at the base of the container. So in that case, it means the solution is already saturated, and you are seeing unsaturated, you are seeing undissolved solutes like salt in the solution, because it's no longer dissolving any salt again. So according to the definition of saturated solutions, a solution that contains more salt than it can actually dissolve at that particular temperature in the presence of undissolved solutes. And for a supersaturated solution is a solution that is actually that is saturated, and you can force it by increasing the temperature. What you use a saturated solution that has undissolved solute, then you increase the temperature by heating, and then you force the undissolved solute to dissolve. In that case, when you eat such kind of solution that is already saturated and you have an undissolved solute in it, when you eat it, the undissolved solute dissolves. But once it starts cooling, when the solution starts cooling, we say that those undissolved solutes that were forced to dissolve by increasing the temperature will start crystallizing out again. They will be appearing out again, especially when there is a scratch in the container. They will be piling up there and be crystallizing to form the salt again. The salt will be appearing. So in that case, I think I've covered the unsaturated solution, saturated solution, and then supersaturated solution. So in this case now, because the question here, in the question, 3.4 gram of salt was given, and we are supposed to have 8.585 gram of salt dissolved in 250 cm cube to give a solubility of 0.34, it means that we have less solute. So the solution is not yet saturated. So the best answer for this question is A, which is an unsaturated solution. So if you see questions like this, you should be able to answer it. You can do it in either way. You can calculate the solubility for 3.4 gram, and you will see that you get a lesser value. So you can use this method to solve this question, which is 90 gram of magnesium chloride was placed in a 50 cm cube of water. So 50 cm cube is the volume of the water, while 90 gram is the mass of the salt. The salt is magnesium chloride. In this case, the name may be written in full and the formula will not be given. You need to learn how to write the formula correctly and then work out the molar mass. So to give a saturated solution of 298 Kelvin, that's a particular temperature. Though in this calculation, we don't need temperature for our calculation. It only reflects that there is a kind of cooling, an increase in temperature or decrease in temperature, but we are not using it in the formula. If the solubility of the salt is 8.0 mole per dm cube at the same temperature, what is the mass of the salts that are left undissolved? Because the solution is already saturated. So what you will do is this. It means that you want to know whether this 90 gram is in excess or not in excess. So the solubility has been given as 8.0. You will use 8.0 here, then put X here. You want to know the actual mass of salt that will dissolve to give a solubility of 8.0. So 8.0 here is equal to X over, calculate the molar mass of magnesium chloride. which should give us like 95, because magnesium is 24 plus 35.5 times 2, which is that is 71 plus 24, 95, divided. And in this case now, you are writing 95 here, x is here, multiplied by 1,000 over 250. By the time you work out your value, you will get a certain mass, which if it is lower, you have to deduct it from this to get your answer, because definitely you will not dissolve, the solution will not dissolve up to 90 grams because the solution is saturated, and they want to know the excess salt out of the 90 grams. So the value you get, the x you get here, deduct it from 90, that is your answer. And then the last part of the solubility calculation is this. The solubility of copper 2 tetrahydrosulfate 6 is 90 grams in 1 dm cube of water. 1 dm cube means 1,000 centimeter cube at 100 degrees Celsius, and 30 grams at 40 degrees Celsius, meaning that at different temperature, you have different mass dissolving. So at 100 degrees Celsius, 90 grams dissolve in 1,000 cm cube, and at 40 degrees Celsius, 30 grams dissolved in 1,000 cm cube as well. So calculate the mass of the salt, which will crystallize out. If it is 40 grams of copper 2 tetrahydrosulfate 6, that is saturated at 100 degrees Celsius, and then is being cooled to 40 degrees Celsius. So this is another dimension. In this case, we are not really using formulae. Now, we want to know the total mass of salt. 1,000 cm cube of water plus the 90 grams of salt gives 1,090 grams of solution. That is at 100 degrees Celsius. So at 40 degrees Celsius, 1,000 cm cube of water as well dissolve 30 grams of salt to give you 1,030 grams solution. So when there was a cooling from 100 degrees Celsius to 40 degrees Celsius, definitely some salt will crystallize out. When there's a cool, the salt will start appearing again because the solution is saturated. Some salt will be appearing again as they are cooling. Those that were forced to dissolve. So we have 60 grams that crystallize out. So it means that 1,090 grams crystallizes out 60 grams of salt. So what if, the question now is, what mass will crystallize out if it is 40 grams? If 40 grams of salt is being used, what is the mass? Or if a 40 grams of solution, copper 2 tetrahydrosulfate 6 solution is used. So what is the amount that will crystallize out? This is the total mass of the solution. In this case, 40. If it is 40 grams that is used, what mass will crystallize out? So we need to calculate that. So we have 1,090 divided by, 1,090x by cross multiplying is 40 multiplied by 60. At this point, 40 multiplied by 60 will give 2,400. And then this is divided by 1,090. The total answer here is 2.2 grams. So it means if 40 grams of solution is used, it will crystallize out 2.2 grams of salt. So watch out for my next video, which is on a series of questions on Jamb, on organic chemistry. And if you are yet to subscribe, please do so by pressing the subscribe button below the video. You can press the notification bell so that you will know if I drop new videos, and like, share my videos. Thank you.